Hi, good morning to you all. This is Dr. D. Srinivasa Rao, working as Associate Professor in the Department of Information Technology, VNR VIGNAN JYOTHI Institute of Engineering and Technology. Today we are going to discuss the topic titled Distributed DBMS Issues and various dimensions to be considered while designing distributed DBMS and its related architectures from the subject distributed database systems. So, as we discussed earlier, distributed database systems is the context where both data and computing environment are distributed. Data and the software related to process the query got distributed across multiple physical locations. So, when you want to achieve the real advantage of distributed database systems, what are the various issues we to consider while designing it in order to get the specified outcomes precisely? Here, distributed DBMS issues are titled as Distributed Database Design First. It tells you about how to distribute the database. What are the various parameters we to consider while distributing the data across physical locations? What sort of replication you are considering it? It's a fully replicated, partially replicated, or non-replicated. And which criteria is required in which context is also important to consider. Then a related problem in the directory management stating that do you have any information with you like what particular data is available in which node or location and how to access it. An indexing mechanism is required to know what sort of data is available at which particular location, so that while executing the query we will see the process to be followed to access the data and to use the data while processing the query and to get the required outcome precisely after the query execution. Then second one is distributed query processing. So query means a question submitted by the user, processing means execution. As query execution is distributed here across multiple nodes, this is the title given, distributed query processing. This is the process used to provide a suitable response or data to the end user, to the query submitted by them. User transactions to data manipulation instructions, conversions here it is required, where what is the user need, how you are handling it, and how this query execution is going to be change the data and what is the final data to be stored to the database. Ultimately, what is the minimum cost you are proposing here to provide the required data to the end user finally? What sort of things available with you to optimize a query processing? And what is the complexity of the problem here you can mention with respect to your data processing system. Third one is distributed concurrency control. Concurrency means two or more queries run in parallel. It is to be controlled and in the environment called distributed environment with the objectives of synchronization of concurrent access to achieve consistency where the data is same while accessed by the different users, different people from different nodes. Isolation of transactions is also very important, where the data authorization it happens perfectly. Deadlock is also possible in distributed environment as part of doing its activities, and there must be a mechanism is required to manage this deadlock, where prevention is the preference, second one avoidance, third one detection, and fourth one recovery. Sometimes deadlock may not be avoided, but here we to handle how you are going to be handle the situation. If prevention not possible, try to provide avoidance. If avoidance is not possible, you to have the mechanism to detect the deadlock. After that, you to recover from that situation as soon as possible, so that your data will is safe. Then reliability is also one more important context, where we are going to be assure you that the query execution is possible, the data is safe, though we are in unforeseen conditions. So here we are looking for the system resilient to the failures which are unavoidable, which are very common. But still, what is the mechanism with you to handle the situation and these troubles and difficult issues which we are not submitting to the user, or end user is finally satisfied with your response submitted. And here we look for atomicity and durability. So irrespective of the transaction size, your execution should be as atomicity, as a single execution with continuous processing, and what the data you obtained from execution is durable for long time. So we too see for the successful execution of the query submitted here. Then comes to replication. So having multiple copies, it's for mutual consistency is required. Then only the data is valid, the freshness of the copy, and we could able to provide updated data to the user and maintaining the same in the physical locations. Eager and lazy. So we have to see that how frequently you are updating the data and replication strategy happened, and see that whether it is a central storage or a distributed storage. So replication, normally the fully replication, partial replication, and non-replication happens. So whenever fully replication happens, the complete data available at all the nodes. Partial replication happens, some of the nodes are having replicated data, and non-replication means there is no replication of the data. So normally here we will see the distribution of replicated data. All the data is available at all the nodes, so that availability is possible, and the query execution is faster. Accessibility to the users as a locality of the reference. Then the parallel DBMS, where objectives like high scalability. So as long as the data is going to be added, as long as the users are going to be added to the environment, there is a possibility of enhancing the infrastructure and to provide the better performance to the end user. Then not geo distributed. So here actually the data is distributed into multiple physical locations, and there is no distance limitation here. But end user illusionation is that single system and a single software which are available to handle our queries. But reality is that the multiple locations spread over the world, equipped with the different DBMS which are ready to receive the user's query, processing it, and providing the required data. Also associated with the clustering computing is required in order to group the environments which are going to be associated and connected well soon. So started with the distributed database design, thinks about how database to be designed in the distributed environment. Then think about how to process the query in a distributed environment with the objective of optimization while processing the query. Distributed concurrency control is also required to achieve the consistency. Also, we to target for reliability of this data query execution and providing the data. This is how replication happens, and what is the role of that. Then parallel DBMS is required in order to perform the things faster way. Then the related queries here, it is also that the modern P2P system is available, and the how the system is connected, and how you are able to coordinate different nodes, different users over the internet and web platform. Here, do you have any role for big data processing, where volume, variety, velocity, and veracity are the characteristics of that, and ability to handle these four cases, like size of the data to be, variety of the data to be, and how frequently it is going to be changed, the speed of processing it is happening, And other facilities like MapReduce and Spark mechanism is available to handle the big data related problems and providing the better solutions. Streaming of the data in this context, how analytics are performed with the illustrations graphs, NoSQL, NewSQL, and Pulse stores. What are the various DBMS systems are available to handle your particular context. So here, in order to uh, propose a DBMS software, I to come up with the DBMS architecture by keeping the points like what are the design issues are, which are discussed very recently. In distributed DBMS architecture's point of view, it, it dictates how data and processing are split across multiple physical computers connected over a network. So the theme of this distributed DBMS architecture tells you about how data and how processing of this data environment are scattered. So here hardware architecture models are listed here as shared memory, shared disk, and shared nothing. In shared memory, all processors share a single central memory pool and disk storage. So it offers fast data transfer but scales poorly due to memory bus bottlenecks. So in this environment, there is a tightly coupled context associated here, and there is a single central memory pool and disk storage are shared among multiple processors. Then comes to shared disk environment where each processor has its own private memory, but all nodes access a common central disk subsystem via storage area network. In this architecture, we too provide the environment where it simplifies the data sharing but risks in the data storage network congestion. So as communication is required among multiple nodes in the distributed environment, there is a possibility of the congestion with respect to the network communication channels. Then third one, shared nothing. So here every node contains its own independent CPU used for processing, memory for storage, and disk storage also, where it is related to the common data. The nodes communicate solely through network messages. So this is the most scalable architecture, and it is preferred in the context of big data engines, where everything is available individually. So the quick comparison required among these three aspects are that with respect to the shared resources feature, in shared memory context, CPU, RAM and disks are shared. In the shared disk, only disks are stored where the common data is available. Whereas in the shared nothing, the all nodes are equipped with their private resources. So there is nothing to share. Then data access, it instant via common random access memory. So comes to shared disk, it's over a storage network. So see that your network is less congested. Third one, over a local and wide area network, here communications happens. Scalability opportunity in shared memory is low. It limited to the machine. Extremely low scalability is available with this offer. Whereas in shared disk, there is a moderate scalability. It's limited by network fabric. Comes to the shared nothing, the scalability is virtually infinite. As system demands and the need demands, we have the option to enhance the infrastructure in this context. Comes to the main bottleneck here, memory bus contention is the problem in the shared memory. Whereas in shared disk, the storage network congestion is highly possible. Comes to the shared nothing, network latency and data skew because of the messages takes place among the physical nodes, and how frequently they are able to communicate, how frequently they are able to send and receive the message, what is the latency and jitter involved in the network communication. It is to be considered here. Comes to the cost of this context, very high because it requires specialized hardware to handle the shared memory distributed system. In a shared disk context, high expense is also required related to the storage area network. Then comes to shared nothing, it is low. It uses commodity hardware where they can have their own infrastructure to handle the context. Then the client server versus peer-to-peer context to be defined here while discussing distributed DBMS architecture. In the client server architecture, normally the client is the one who are expecting service from, who are able to prepare the request, who are able to communicate with the server to get the service from. Server is the system who is equipped with all required things, who are capable of receiving the request, querying the request, and processing it. So server is for serving to the clients. In the single server, multiple client machines handle user interface and queries, but a single central server manages all data storage and transaction logic. They are capable of receiving the request from the client, processing the request, and providing the required data to the client at the end of the discussion. In multi-server, data is distributed across multiple backend servers. There are multiple servers are available here. They are associated with different clients across the world. They are connected to a specific coordinator server, and which routes request to the appropriate data nodes. So clients have the information connect to a specific coordinator server, and they are able to submit their request and to get the response finally. Here in the peer-to-peer architecture, every machine acts as both a client and server. So in client server, there is a hierarchy. Client is always expecting the service. Server is always above the level who are ready to provide the service to the client. So hierarchical level. Client is the low level and server is the high level. But comes to peer-to-peer context, what will happen is that every machine acts as a client and server. If it is expecting some service and response from the colleague, it is a client. When it is ready to provide the response and some information to the colleague, then it will become a server. So no single node controls the system. No, all the machines in this architecture designated as at the peer-to-peer, and there is no structural hierarchy here. All of them are having thus equal resources, equal capability, and equally designated. The nodes autonomously collaborate to execute queries, replicate data, and maintain the consistency. So they will be like a classmates in the particular section. But whereas client server, it is the link between student and the faculty, faculty and the head of the department, head of the department to the principal, principals to the management. That hierarchy is there with client server architecture. But there is no hierarchy in the peer-to-peer. All are same with the same number of resources, same type of resources, same type of activity, and same type of capabilities. In the homogeneous and heterogeneous system, homo is just that all are same, hetero is different. So in homogeneous distributed DBMS, stating that every node runs the exact software, like PostgreSQL, the one installed in all the nodes, or all the nodes installed with the Oracle. The nodes are fully aware of each other, making data sharing, schema design, and global transaction management highly efficient, because all of them are equipped with the same type of DBMS. No translator is required, no difference is mentioned, and no difficulty is possible here. But comes to heterogeneous DBMS, it is a federated, where nodes run completely different DBMS softwares, utilize distinct data models. Some of them are with SQL, some of them are no SQL, or use varying schemas. It requires a dedicated middleware layer called translator to translate queries and unify data formats as required. Then data distribution strategies, like this architecture is further defined by how data is physically laid out across the available nodes, which are scattered. What is the role of replication here? And fragmentation happens here. Here replication is required whenever you want to have the same data at all the nodes, locality of the reference. Fragmentation is required. It is the process of converting horizontal fragmentation, vertical fragmentation, where conversion happens from master relation into sub-relations. If you are having fragmentation with respect to the rows, it is horizontal fragmentation. When you are fragmenting the relation into a column wise, it is called vertical fragmentation. There, what is the physical node requires the exact data is provided. If node 1 need to have first to 100 rows from the relation, so it is provided. Then 101 to 150 is required by node 2. Then 151 to 175 required by node 3. Like this, we to divide the relation into horizontal manner where each node will get what the data it wants to have with it. Like that, if you are doing this fragmentation in a column wise, it is called vertical fragmentation. Here, there are DBMS implementation alternatives is considered while designing a distributed DBMS with respect to the dimensions called autonomy, distribution, and heterogeneity. This is the diagram illustrating the prospects involved in implementation of distributed DBMS architecture. So here, the dimensions of the problem considered it is as a distribution where whether the components of a system are located on the same machine or it is distributed. So in distributed environment, the components will be distributed. In this particular environment, we are with the heterogeneity, not with the homogeneity. So in the heterogeneity context, the various levels may be hardware, can be CPU, memory, IO, can be having different natures. Communication is also in heterogeneous manner. The operating system used by different nodes at different physical locations are also heterogeneous. Then the DBMS important one, it is the data model used here. The query language we followed here, transaction management algorithms we implemented here is also different. Then comes to autonomy, it's stating that the nodes which are capable of taking their own decisions. So we will be having design autonomy, communication autonomy, and execution autonomy. The design autonomy stating that ability of component DBMS to decide on issues related to its own design. Ability to take the decisions with respect to the design aspect. Ability to take the decisions in the communication aspect defined as communication autonomy. Ability to take the execution is called execution autonomy. In the distribution environment, you to tell about whether it is locally distributed or available as the centralized aspect of that. So all data on the DBMS software reside on a single physical machine is locally available, and it's also called centralized availability. In distributed context, the components of the data and processing are spread across multiple machines in order to justify and to give the strength to the distributed database systems. And in this distributed database system, heterogeneity is the primary property where the diversity of technologies used across the different nodes which are proposed here may be hardware. The nodes may run on different CPU architectures or machine types rather than the same type. So the communication is also heterogeneous. It nodes use different network protocols and different topologies to support their environment. Then operating system is also different. Systems are split across Linux, Windows, or Macintosh platforms. It is compatible with their context defined. Then DBMS specifications, the most critical aspect of that, the nodes differ fundamentally in data model, query language, and transaction management system. The autonomy, it is defined here, it is what sort of autonomy defined for? Design autonomy, communication autonomy, and execution autonomy. In design autonomy, the database can choose its own data models, the schema designs, and constraints to be imposed, and physical storage structures without any external approval. That particular self-decision power is available with them. Whereas comes to communication autonomy, the local database decides what information it shares, which systems it talks to, and when it will respond to external global results. That individual decision making power is available with respect to the communication strategy. Then comes to execution autonomy tells you the local database executes its own transactions however it wants. It can prioritize local users and abort global transactions if they are conflict with their local work. So they have the complete decision power capability in order to execute the query which receives. Thank you for your attention.